Dan here from Hardwood Hollow's Beyond Bushcraft Skills channel. Coming to you, we've got an unboxing today, and then it's also going to turn, this unboxing is going to turn into a welding project. This was sent to me by the Tab and Slot Company. Their website is weldtables.com. The reason I ordered this is that I actually got it for free, just for the cost of shipping. It's normally around $35, and it cost me $19 for shipping, so in the end this cost me $19 to have it shipped to my house. What it is it is a excuse me, it's a assemble yourself welding square. So let's open it up and take a look, see what we got. Put the box aside, it's flammable, so we don't want it on the welding table. What you have inside the bag is you have 4 parts, 2 sides, a top and a bottom. That's exactly how it came shipped to me in this plastic bag, which, given the blue color, I'm inclined to believe that it may be the anti-corrosion bag to prevent any rust from forming on the metal parts. They are unprotected. We'll go ahead and put that aside. So these 2 sides are exact. These are not. You've got both male and female sides, as you can see. They're going to fit like that, only upright this way. So let's go ahead and assemble it, and you can see how it goes together. So it's going to go this way, and then this piece is going to fit on top. And the reason it's called tab and slot is, if you look, all of the weld joints are tabbed and slotted so that when it fits together and then you weld it, everything stays square. Now this is a welding square that you'll use on your workbench to, say, hold up a piece of work that you're working on. We'll take this piece of metal right here, say I want to put it up against here and then weld something flat across it. I can push it right against here and it'll stay square while the work is being welded together. So since this is going to be a welding project, let's go ahead and go over some of the welding tools and safety equipment that we'll be using today. Alright, we're going to start with the usual welding hat. Doesn't really need description, but I'll say real quick, it's just I don't have any hair on top, so a welding hat keeps the slag off my head. We're welding indoors. Now I have a fan blowing across the work table, blowing this way, blowing right across this way, and my door is over there also, going outside. I have a pair of fans blowing that towards the door because in my basement here I have a smoke detector, but the fan is right behind the smoke detector. Then I have this hood over here, so let's see if we can get so you can see that hood. See that hood right there? That is connected to my shop vac, which is sitting outside, and that hood, I'm using it as a fume extractor, so while I'm welding on the table, I'll set that right over here by the weld, and it'll hopefully suck most of the fumes out. So when I am welding, between the fans going, the welder fan going, and the shop vac going, I'm not going to be talking, I'm just going to be welding, and then you guys can watch. So got the welding hood, the welding hat, like I said, my respirator. This is a welding specific respirator from Miller Welding. Because I don't have a argon tank, I weld with flux core. So flux core creates a lot more spatter than regular MIG welding. A lot of people confuse MIG welding and wire feed welding as the same thing. MIG welding stands for metal inert gas. That inert gas is a argon mixture or pure argon, depending on what you're welding. Standard welding with carbon steel, you're generally doing 25% CO2, 75% argon. When you're welding stainless steel, you're usually using 100% argon, and when you weld aluminum, it's usually 100% CO2 if I'm not mistaken. Don't quote me on the last one. I don't weld aluminum. So I take this anti-spatter gel, I take the nozzle of my welder, I tip it right in there, dip it right in there, and that coats the inside of my welder so that it will not build spatter up inside of it. Now, if I'm doing some sensitive welding that I don't want spatter to stick to, I can actually take this with a brush and brush it on the work that I'm working on, and it'll help make getting weld spatter off the metal a little bit easier. I'm not going to do that today. Other tools we're going to use, obviously, our welding helmet. This is just your standard. I've had this thing for pushing 30 years. It's just your standard, what they call it, a MIG welding helmet. Oh, I messed up on the metal inert gas. That's when you're using the argon. When you're just using wire feed, it's what they call flux core wire. So when you're stick welding, the flux is on the outside of the welding electrode. In the case of MIG welding, wire feed welding, the flux is actually on the inside of the wire. So the wire is a hollow tube that's filled with the flux, and the flux is there, if you don't know, to do the same job as the argon gas would, and it's there to purify the environment right at the spot of the weld in order to make the weld stronger. When we're doing any kind of grinding or anything, I'm going to have my ear protection and my eye protection. I usually wear clear eye protection behind my mask. I don't need to show you safety glasses. Anybody that's done any welding also knows what welding magnets are. This is a small pair, and then I also have a larger set, and I'll be using these to keep the square while I'm working on it. Also be using MIG welding pliers. These are invaluable when you're doing welding, MIG welding or wire feed welding. They can serve a whole lot of functions. If you need to take the nozzle cover off, at the very back of the pliers, right here, there's a spot that will slide over the nozzle, and I can then remove my nozzle. Whether it's a slip-off style like mine or threaded style, it can help you get them off. Now see, when I've been welding a lot lately, I see there's quite a bit of gunk on here, so I'm going to use my wire brush. This one happens to be a stainless steel wire brush. I prefer them over spring steel brushes. So I'll go ahead and clean some of this off like this. Now, since I have this off, you also have a second set of round jaws on this plier, and that is for your tip. So you slide your tip in here, and it'll unscrew your tip. So there's a few things, plus of course the wire cutting function and everything else. So you slide in there. Well, I'm going to have to tighten that up with a wrench. Luckily, my wrenches are right here. There we go. So you can see that my wire in the tip is bent. So there's also wire cutters on here, regular wire cutter jaws. So I'll go in there and I'll just nip that end off. And since I loosened it, I can now unscrew this tip. And then remove it. Now what I'm going to do with this tip is, you'll notice the tip is kind of dirty, so I'm going to go over to the polishing wheel and clean it off real quick. Okay, now if you don't have a polishing wheel like I did, a simple piece of emery cloth and your tip, and you can sit there and clean that tip off nice and easy. What you're trying to do is you're looking at it to see if there's any silver on it. It's a copper tip. If there's any silver on it, the metal, when you're welding, the spatter, that means there's spatter stuck to it. So welding, cleaning off that spatter will make it for a nicer weld. I'm also going to be wearing a welding jacket. It's not really cold, and the welding I'm doing, I really don't need my leathers, so I'm just going to be wearing a cotton welding jacket. It's cotton, but it's treated, heavyweight cotton. It's treated with fire retardant material. This one happens to be from Hobart. So let's go ahead and get this put back together. Screw that tip on. Really, that tip doesn't need to be any more than hand tight. Since we have this cover off, we can clean that out too, and again you can use the pliers. Notice the long needle nose tip on them. That needle nose tip is for getting down inside of here and scraping that gunk out, and you can see the gunk on the pliers there. So you can also, if you need a little bit of sharper edge, you can go in this way and use that sharp edge to clean that off, or clean that out, and then we can wipe those off with pliers, and then I'll go ahead and give this a quick brushing. Now let's go ahead and throw it all back together, and since I've done all that cleaning, we'll give it another dip in the gel. You can do it cold or hot. If the welder's hot, it'll actually penetrate, the gel will penetrate into the stinger a little better. Alright, just about time to get welding. Give you another little tip: if you wear a digital watch like I do, especially on a hot day when I'm welding, when the current's near that, I've actually seen the screen go black. I don't know if it's from the electricity or from the heat or what, but I go ahead and take my wristwatch off and drop it in my pocket. Plus, it makes it easier when I'm tightening the cuffs of my jacket down, and then when I'm wearing my welding gloves. Which was, of course, one more tool I didn't mention, welding gloves. They do make thinner MIG welding gloves. I have a pair of them that came with the welder, but I had a couple other pair of leather ones, and I just heavier leather ones for regular stick welding. They're gauntlet gloves, so they come all the way up your arm, a good ways to protect. What I do is I tuck the buttoned up sleeve of my jacket down inside the sleeve of my glove, the cuff of the glove, and that protects my hands very well. I also wear these same ones when I'm grinding and stuff. If there's any question whether they work or not, see that scar in my thumb right there? That was where the grinder came back and bit me. And same thing on the finger of this one, and right here the grinder bit those spots. So always wear my gloves when I'm welding and or grinding. Alright, let me take you off and we'll show you the welder I'm using today. Okay, this welder is the Hobart 210 handler. It cost me, I want to say, around 800 bucks. It's 210 amps. It's got a number of settings. The top setting is, this is your power switch. This is your wire feed speed. This is your amperage. You've got 7 levels of amperage. This light comes on if it goes over temp, which means you've exceeded your duty cycle. So this one's maximum duty cycle is 34, which means that I'm sorry, 30% duty cycle, which means that out of every 30 minutes you weld for 10 and then you let it rest. I believe that's what it stands for. Easy to look up. I just don't have the facts and figures at the top of my head. I'm a hobby welder. I have been hobby welding for a long time, both with MIG, TIG, wire feed, arc. But right now, my own equipment, I own this wire feed welder. I've got a 110 volt wire feed welder, 90 or 95 amp, and then I've got a stick welder. I've got one up on the workbench there in parts I'm trying to get back together. That one was given to me. It's an AC DC stick welder, and then I have a straight up AC Lincoln stick welder as well. So this is what we're going to be welding with. I turned it down to 3 on the amperage scale, on the power scale, and to about 42 or 3 there on the wire feed. We'll give it a test on a piece of scrap and see how it welds. I don't want to burn too deep on this. This project is 1/4 inch steel, but where I'm going to be welding in these tabs and slots, I don't want to over penetrate and burn through. So I've turned my power down just a little bit, and hopefully that'll be good. Let's go ahead and crank her up, and we'll get the camera reset, and we'll take off from there. Okay, what I'm getting ready to do here is I don't normally weld indoors. I usually weld outside or on the concrete over here, but because this is such a small project, I want to do it up here on my welding table. But this particular welding table was a production table out of a factory, and it is 1/4 inch steel plate for the top, but it's been used for so many years it's not level anymore. So I put this heavy plate, this is like 3/4 inch thick plate, I've set it on top of my table. I ground it to get rid of most of the a lot of the scale, so I'll be able to get, when I put my work on here, I'll be able to set the metal down here, and it on its own will get a ground connection, because my ground connection is grounded to the table over there. So what I'm going to do is I cleaned off a spot on two spots on this plate of steel to keep it from moving, and I'm going to actually tack weld them to the table. That way I'll get a good complete ground from this plate to the table to the ground clamp over in the corner. So that's what I'm going to do right now. I'm going to go ahead and do these 2 tack welds. Alright, now the steel's not going to move, and I should have a good ground on this plate. So I'm going to come up here to the corner that I'm not going to be using, and I'm just going to do a test and see if I'm getting a good ground. So I'll put this little plate up there and see if it'll weld. I'll hold it in place with one of these welding clamps that I mentioned. So we'll set that welding clamp there, set my piece of metal right on it, so now it's right there. Now let's go ahead and see if it'll tack weld. Alright, that was a successful test. It will tack weld, so now I'll get everything set up and we'll start welding on that. I got to turn on my fume extractor, get my mask on. So I just did a quick spot weld, so it popped right off. So we'll get everything set up, be right back. Okay, I have everything set up now, it's all jigged up. I've got the magnets here holding the sides together. I've got this clamp so that everything is tight with the vice grip pliers. What I'm going to be doing is, again, tab and slot. So I'm going to come in and I'm going to weld in this slot, this slot, this slot, this slot, and this slot. Once that's done, I'm going to come back and I'm going to grind the sides and the face flat. I'm going to use my Milwaukee angle grinder, and I have a flap disc wheel on here. This is a coarse, like 40 grit flap disc wheel. That'll go ahead and take everything off. Then I can flip it over, rejig it, and then I'll be welding this back side at that point. When I come back, I'm just going to start welding. It's going to be loud because I'm going to have everything going, so watch your volume. I'm going to have the welder, all the fans, and the shop vac going. Alright, I'll be back. got that side welded up, and now we'll move on to this side. Alright, here we go. She's all done. Got it welded up. I got it squared off with the sander. Now, the other thing that you can see is these holes here. These holes are designed to match up to the strong hand style clamping system, so that if you have a welding table, which this company also makes, weldtables.com, I'll pin it down below in the description, you can use these, and they have a number of clamps. Like, they'll have clamps similar to these pliers, but instead of having two jaws, they'll have a flat side, and that flat side can clamp down to the table, and it fits into these holes, and then when you clamp it down, it actually puts upward pressure, which puts torque pressure on the bolt, or the stud that goes into the hole, and that helps to torque it down. It's hard to describe, but they work. This company does not sell those clamps, but their tables are designed for it. I spoke to the owner of the company, and he's going to be sending me a 2 by 3 foot welding table that I'll be able to assemble, and it's going to get mounted on top of this table, and that'll give me a perfectly flat, certified flat welding surface. And then if I purchase some more of these, I can use them to clamp down on that table in order to hold my work square while I'm welding things up. So thank you to Dave from Tab and Slot, also known as weldtables.com, and we'll catch you on the next video. And when I get that table in, probably won't be until next after the first of the year, we'll go ahead and get that welded up, and that'll be on video also, show you how the whole system works together and everything. Alright, thanks a lot, have a great day. Dan, Hardwood Hollow's Beyond Bushcraft Skills channel, I'm out.